All right, so now we're talking about capacity of our battery, the next kind of specification here we see on the battery. This is 1400 milliamp hours and 1.4 right here. So why does it have two numbers, right? This one has 5000 right here and then 5.0 right here. Okay, same thing for a lot of these, right? Now, a lot of this, selling batteries is just like anything else, there's some marketing involved. 1.4 looks really big and cool and whatever on the battery. So 1.4 is right here and 1400 is right here. Now this is in milliamp hours. 1.4 is in amp hours. So if you remember your digits in your chemistry or science class, things like that, if you go from milli to just amp hours, okay, from milliamps to amps, we'll take our decimal point and we'll go 1, 2, 3, 1.4. Or we take it from amp hours to milliamp hours, we extend it 1, 2, 3, add those two zeros on the back, and we get 1400 milliamp hours. Okay. What this measurement here, whether it's milliamp hours or amp hours, is a measurement of the capacity of the battery. Okay, battery capacity is kind of like the fuel tank, we'll say, for the battery. Okay, so if you have a bigger fuel tank, you can go farther, right? But your fuel tank also weighs more. Okay, kind of the same thing here with the batteries. You can find a 3-cell battery that's 1400 milliamp hours or 2000 milliamp hours or 5000 milliamp hours. Okay, this one right here is a 5000 milliamp hour 3-cell battery. Okay, so these are both 3-cell batteries, and one is obviously much larger than the other one. I can't fit it on screen right now. And that's because it's got a larger capacity, right? So that you can't just get something for nothing, right? When we increase in capacity, we have to increase in physical size. And so that is the capacity of the battery. And as you look at different aircraft and different drones and things like that, you may have different sizes of batteries you need to use for different aircraft because of not only how long do you want to fly, but how heavy can the aircraft lift. So you can't just throw a huge battery in an airplane and expect to fly forever. If the battery is so heavy the airplane has to fly full throttle to stay in the air, you're going to burn through the battery a lot faster. So as with many things, there's a balance point where you say, okay, this battery is big enough that I get a good flight time, but small enough that it's not too heavy where the plane can't fly very well. Same thing for a quadcopter. Okay, so there's our second number there. That's capacity. Okay, so we have our voltage count and our capacity both in milliamp hours and amp hours, right? We know there's 3 cells in this battery. And what's the last number here, this last little thing that we're going to worry about anyways? Some batteries will list other specs and things we'll look at as well. But we can see here that it says 40 to 80 C discharge, 15.54 watt hours. I'm not going to worry too much about watt hours, okay, for the purpose of this discussion, but we're going to focus on the 40 to 80 C discharge rate. Okay, so that discharge sounds like it's putting something out, right? And this 40 to 80 C. So what's this C? It's kind of a mystery number here. So let's back up a little bit. We'll do some more whiteboarding here. Okay, so our battery is 14. Oh, my marker dried out that fast. Wow, 1400 milliamp hours. Okay, and we have 40 to 80 C. Okay, so the trick to this is figuring out what this actually means in terms of like amps, because most aircraft will say, hey, if you go full throttle with this aircraft and this motor and prop combination, you're going to need to supply 50 amps of power or whatever it is. There's specification sheets for that kind of thing, and you want to make sure your battery can handle the demands that it's going to get. If I have a motor prop combo, so we'll just draw a little motor here. Here's our motor, here's our prop, okay? And this motor prop combo, there we go, artistic liberty. There's our motor wires. Okay, so this motor prop combo is going to request or ask for, let's say it's going to request, I don't know, 30 amps at full throttle. Okay, so if this setup for your plane requires 30 amps, you say, well, is this battery going to work? How do I know? Right, so the way you know is your discharge rate. That's how much power the battery can put out. Okay, and so to get this number into amps, we have to do a little bit of math. Okay, so we're going to take our capacity. Oops, there's no decimal point there. Sorry. 1400 milliamp hours. Okay, you're going to divide by 1,000. We all know probably what that is. 1.4. Okay. 1.4 is going to be the amount of, basically the amount of amps in 1C of this battery. Okay. So we're going to say amps equals 1C. Okay, so up here we have 40 to 80C. So once we know that 1.4 amps is 1C, let's go over here. We'll say 1.4 times 40, 1.4 times 80. Okay, let's do a little, get my calculator out real quick here. I want to show you guys on screen how much math I've forgotten since I was in school. All right, so we have 1.4 times 40 equals 56. And then we have 1.4 times 80 equals 112, which I guess those are just doubled. Okay, so that means at 40C discharge rate, this battery should be able to put out 56 amps. And at 80C, it should be able to put out 112 amps. Now, what you say, why are there two different discharge rates? Why is there 40 and 80, right? Typically, when manufacturers list two discharge rates, the first one is a continuous rating, as in the battery can put that out continuously, for multiple minutes, potentially, depending on the size of the battery. And then the second one is a burst rating, so maybe for 5 seconds or 10 seconds, the battery can put out that many amps. And now this is just amps in a void, right? It doesn't mean you're going to get 56 amps for 10 minutes. We don't have time as a unit here. We just have the amount of amperage that can come out of the battery without damaging it, period. Okay, it could be for 10 seconds. We have to do some other calculations to figure out how long it would actually last. But in this case, we're just trying to figure out if this battery can even support this powertrain. Okay, typically you don't fly at 100% throttle all the time either. We're doing kind of maxing out this and saying what can the battery give us. Okay, so in the case of 40C, 56 amps. So this battery should be fine to support a 30 amp powertrain easily at 100% throttle, and we have plenty of overhead, right? We can do some more calculations here in a little bit. I'll show you guys some calculations to figure out how long this battery would last with this powertrain if you were to fly at full throttle the whole time, or whatever throttle setting, kind of an average there. Okay, so hopefully that makes sense. The C rating of a battery is its discharge rate, but it's kind of a function of the capacity of the battery. Okay, so let's do one more example like this real quick. Okay. Get this on the screen. There we go. Okay, so this other battery here, this is a 5,000 milliamp hour battery with a 20C discharge rate. Okay, I don't care how many cells it has actually in this calculation. It doesn't even matter. Okay, but this one happens to be a 3-cell, and it's a 5,000 milliamp hour with a 20C discharge rate. So we're going to say 5,000 milliamp hour, right? Okay, and divide that by 1,000. We all know we get 5 amps equals 1C for that battery. Okay, my focus is, there we go. 5 amps equals 1C for this battery. Okay, and this battery has a 20C discharge rate. So we just take 5 times 20. Okay, we'll say 20C is the discharge rate. 5 times 20 equals 100, right? 100 amps. And if we just have one rating, this one doesn't have two ratings, it says 20C discharge. We're going to assume that that's a continuous rating. You would want to look at the manufacturer's spec page and make sure. We're going to assume that's a continuous rating though in this case. So 100 amps is what this battery can put out continuously until the battery is discharged. Okay. Let's look at a really small battery for one more example here. Let's scoot this over a little bit. There we go. This is a little teeny guy, okay? 650 milliamp hours, 650 milliamp hours and a 70C. I know you guys probably can't read that very well on the camera, but that's what it says. 650 milliamp hours and 70C. So this is a very small battery. It's for a small drone, a little small racing drone, like we had them in the FPV class. We use some of these. Okay, it's got a 70C discharge rating. Okay, so now I have a number that's less than 1,000, right? It's a small battery. Okay. So 650 divided by 1,000, take our decimal place here, right? And go 1, 2, 3. Oops, am I doing that right? Yeah. Divide that by 1,000. Sorry, take the decimal place here and go 1, 2, 3. Okay, equals 0.65 amps is 1C. Okay. going to take 0.65 amps times 70. Get my calculator out again here. 0.65 times 70 is 45.5. Okay, so 45.5 amps is the discharge rating of this battery. Again, we're going to assume continuous because it doesn't tell us otherwise. Okay, so that means this little battery can put out 45.5 amps, right? Probably not for very long, but at least it can go up to that much without damaging the battery. Okay, if you try to pull too many amps out of a battery and it's not designed for, basically the battery starts to heat up as you pull power out of it. And so if it heats up too much, the battery can get damaged, get overheated, light on fire, lots of different things. But you don't want to overdraw your batteries. They'll definitely get damaged at a minimum. Okay, so with the different illustrations, what I wanted to show you guys was, you say, well, why does this little teeny battery have such a high C rating, 70 C, right? That's more than this big one, right, which was 20 C. It's in the middle range of this one, 40 to 80 C, okay? So if you need to get a large amount of power out of a really small battery, you have to have a high C rating because the amount of power you get out of the battery is a function of both the C rating and the size of the battery. So if my battery size gets smaller, my C rating has to get bigger for me to get the same amount of power out of the battery. Okay. On the flip side, if my battery capacity gets bigger, like this battery's huge, right, compared to this one, almost 10 times. Okay. If my battery capacity gets bigger, my C rating can get lower, and I can get the same amount of power out of the battery. That's important because you typically pay more money for a higher C rating on your battery compared to other batteries of the same size. Sometimes you can buy literally the exact same size, physical size, and capacity battery in different C ratings. So I have a 5,000 milliamp hour 20C and a 5,000 milliamp hour 30C and a 40C and a 50C. As the C ratings go up, it will cost me more. That's because the manufacturers have to manufacture the cells in a different manner so they have less resistance and can give out more power without overheating and blowing up and that kind of stuff. Okay. So capacity of battery is really important, not only for the physical size, right, but because it affects the maximum power you can get out of the battery. And that's, of course, important. If you know what aircraft you're going to fly, you probably have a decent idea of how much power it's going to draw, potentially, or maybe you don't. And that way you can figure out, use kind of some powertrain calculations to figure out how much battery you need to pay for, basically. I mean, you can always buy a battery with a really high C rating and everything and just do that all the time, and that's fine, but you're going to spend a lot of extra money that way that you probably don't need to. All right. Okay. So we've covered the capacity, the cell count, and the discharge rate of these batteries, right? We're going to look a little bit more in the next clip here about the connectors and charging and discharging batteries as well as some slides. We'll see you there.